We're now going to move on to our last speaker of the session. I'm happy to introduce Robert Norvill. He is a senior data scientist at Banking Circle, and he's going to be telling us about an application built on Flower called Flame. And this is all about how you can start to perform some of these important data analytics tasks that they do in banks using federated learning, where he has been using Flower for this proof of concept now for a little while.
So thank you everyone for coming. My name's Rob, as mentioned. I'm a senior data scientist at Banking Circle. Before that, I was with the University of Luxembourg, where I got my PhD working on data trading with banks for KYC specifically. And today I'm going to take you through Flame, or our federated learning for anti-money laundering enhancement system that we built and use in Banking Circle. So I'll take you through who we are as Banking Circle, what we do for AML, or anti-money laundering at present, why we have a use case for federated learning, and then what we built. So if you haven't seen us on the high street before, it's because we're a B2B bank. So our customers are all corporations, businesses. We have offices in Copenhagen, London, where I'm based, Luxembourg, and Singapore. We facilitate 10% of European e-commerce payment flow at present, and we're growing. We're a scale-up, so that will continue to go up as a percentage, we hope. And this means we process up to 1 million payments a day. And all of these we have to check to make sure they're not fraudulent. So we're dealing with quite large quantities of data on a daily basis. Overall, we exist to make international transactions, financial transactions faster and cheaper. Today, it can take 5 days and cost 50 euros to process international transactions. We think it should take 5 minutes and cost 50 cents. So what we do as a bank, as a financial entity, is try and put all the infrastructure and systems required in one place to make this cheaper and make this happen. And part of making that happen is making sure we can do anti-money laundering efficiently. So what anti-money laundering means for banks is that we have to check that every single payment that goes through us is not fraudulent, that there's nothing bad or criminal going on with it. If you're dealing with 1 million payments a day, you can't do this by hand, obviously. So we use machine learning to do this. In practice, it goes in a few steps. We screen the payments, try and identify any suspicious behavior. And if we find it, we have to report it to the regulatory bodies or authorities. So that's the FCA in the UK, for example. Regulation for AML tends to go one way, which is more and more of it. There's more now than there was 10 years ago. And we keep talking about adding more and more as we go forward. So that creates us an increased regulatory burden for banks. It means we have to do more and more work to make sure that we are catching the transactions we should be catching, and that brings cost with it. So to try and handle that cost, we've built a machine learning-based transaction monitoring system. There's a few different parts to it here, but the one that's relevant for us today is the supervised models bit. Part of that we use a neural network for, to look at each transaction and figure out and score it on whether it's a good or bad transaction. And crucially, we take feedback from the analysts that look at the transactions. So when a transaction scored high, it goes to analysts and they tell us, yes, this is suspicious, or no, it isn't. And that's fed back into retraining our machine learning models. So a few key points about how we do machine learning. As I mentioned, it's a neural network, so we use TensorFlow. Inputs are information about payments. So we actually have quite a lot of these, over 60. But I mean, some of them you could guess, right? Value, sender, receiver, the message that's sent with the payment, the region it's coming from, the region it's going to. These are features for us. The output, 0 to 1, how suspicious a payment looks, with 1 being the most suspicious possible. As I mentioned, if it's above a given threshold, it's sent to analysts to review, which means we care a lot about our model performance, because if we send too many things to the analysts, so if we're getting a lot of false positives, it's too much for them to handle. They can't review 1 million payments manually, so we have to be quite selective about what we send to them. On the other hand, if we have the other way around and we're not sending suspicious payments to be reviewed, so if we miss them, then we're letting criminal activity take place from the point of view of the law. So we do have to catch the bad transactions. So it's kind of a balancing act, but we have to get things right here. And I think it's worth saying something particular about payments data is that there's a really extreme data imbalance. So there's not many fraudulent transactions at all. Even if you're dealing with 1 million payments a day, you still don't see too many. So we use a lot of upsampling and things like that, but the data set is very, very imbalanced when you're working with payments. So our federated learning use case. As I mentioned, we're a growing company, a growing bank, and we're launching in the US now. We're just pending getting a US license, which we hope will come through very soon. And that means that we need fast, efficient anti-money laundering or transaction monitoring in the US, as we have currently in the UK and Europe. And this is where we think federated learning can help out. So here, there's a few things. We can use the model we have in Europe, in the US, but US transactions are not European transactions, so there might be some differences. That might not give us high enough accuracy. It's tricky to share data across borders. I think some of our other speakers mentioned this as well. It's a little easier to store US data in Europe, easier than it is to store European data in the US. But generally, we split these. You have to keep them separate. It's legally complicated to mix these two. Because the US bank is a new entity, it will start life with no transactions. So we have no data to learn from in the US when we start. And what we want to do with federated learning is get a high performance model in the US, even without enough data. And when I say enough, I mean enough to train a model to high accuracy. We don't, because we'll start with no payments, there's going to be a long period of time where we don't have enough payments to train a pure US model. We have to be data protection compliant. As I mentioned, we can't really share data between the two, so federated learning is a good fit for us. And as a bonus, we might be able to learn from the US in the future to help in Europe as well. So our primary goal here is better model performance in the US, but we might also get performance coming back the other way and helping us out in Europe as well. So that brings me to our solution, Flame. Every time I present this, I kind of feel like we're cheating a little bit in federated learning because we have a grand total of 2 clients, not thousands and thousands. One is our US bank, the other is our European bank. So it's not heterogeneous or anything like that. As I said, our main concern here is very, very high model performance. So we have US payments coming into the US side, European payments coming into the European side. Both of those sides have a Flower client. We have a Flower server in the middle. At the moment, the system has the server spin up first, and then the clients spin up as and when we need them. It's all short-lived, although that might change in the future. And then we can retrain our model there with as many US payments as we have. So potentially working with ever larger amounts of data as we go forwards. But that's what it looks like. As I mentioned, we're primarily concerned with performance for the US side, which means if we need, we can weight things such that the US side performs better, even if it damages performance in the EU, because our federated model, at least initially, will be our US model. So that gives us a little more room to kind of play around with what we do with the model if we need to. For the first training, we start the US with the EU model. So they both start with the same model trained on European data. And then we retrain, probably weekly, we think at the moment. And each retraining will use the US model. And the idea here is that as we go along and we do get more and more payments in the US model and the US payments take more and more influence over the federated model as a whole, until eventually it can stand alone. And at the point where it stands alone, then we hope that we can see performance coming the other way and helping out the European model as well. So we did some experiments to test this. Because we're still waiting on our US license, we don't have live US data to test with yet. So we took our European data and did as best as we could to simulate what it might look like if we did have US data. So we split it in two with holdbacks for eval and test. As I mentioned, it's always oversampled training data because of our imbalance. We use a good old federated average weighted on the number of payments, which is number of records for us. And then testing. a baseline is tested on one of these splits, so one data set, and the federated model is trained using both splits, so our simulated EU and US data sets. Results look like this. It depends a bit how you split the data because we're simulating here. It's not actual US data, but we're seeing up to a little over 60% increase in precision. And we're also getting increases in recall and accuracy against the baseline. So this is perfect for us. This is exactly what we'd hope to see and why we will use our Flame flower-based system in production when we have US transactions. We also did an unfair test, which is federated learning versus a model trained on all of the available data. And federated learning held its own. You can see it's not quite there, although in one case it's not quite there, in the other case it was actually better, weirdly enough. But the point here is that federated learning was equal with a model trained on the whole data, which again is quite positive for us. It looks like we will be able to do what we need to do with federated learning. Future work, go live is the obvious one. As soon as we get US payments, I'll come back and hopefully tell you how awesome it is and how well it works. And assuming that goes well, the other thing we're looking at is a single system using Flame. So at the moment, we have a federated setup for training our US model and a different system for our traditional machine learning. And what we want to do is use Flame and Flower for all our machine learning models. So that means using Flame as to do traditional machine learning as well. So our idea is we can launch jobs, whether it's to both our clients or one single client, and train all our machine learning models that way. So we have one kind of unified way of doing things. So that's something we're exploring. If we look a bit further into the future, what we've done here kind of is already federated learning between banks. It's just that both these banks are part of Banking Circle. So we see kind of the opportunity and the scope in the future to work with even more banks. So I think it's interesting here that there's potentially a wider collaboration on anti-money laundering between banks because we're not sharing data, because we can keep things private. It doesn't have to be just Banking Circle in here. We can have other institutions, other banks, potentially from other parts of the world, and see if there's anything we can learn from one another in a federated way there. So that's a kind of quick tour of what we've done with federated learning, how we do it. If any of that was interesting to anyone or the collaboration idea sounds useful, then my email address is on the screen there. I'd be happy for you to get in touch with us. Thank you.
Thanks so much. So we have time for a couple of questions. It certainly is a great use case of federated learning, I think. Any questions from the audience or online? There's okay, we'll take one from I bumped the button. It's okay. You can hear it. Say something. Hello.
Yeah. Okay. Thanks for the interesting talk. Which features do you use? So your data set.
Sure. So I mentioned them near the start somewhere. Excuse me, flicking all the way back through. Yep. So it's information about payments. So value, sender, receiver, the message, things like that. We have a lot more. Some of them are kind of calculated fields. We have around 60, maybe a little over 60 in total, but information about payments. Yeah.
Yeah.
One online.
Yeah. So the question is, do you know of public reference data sets for anti-fraud or money laundering? And will the data used be anonymized and released?
So to answer the first one, yes, there's some public records out there. Obviously, if they're useful for us as a bank, we do already make use of them. The second part was?
If you would anonymize and release your data, I guess.
I'd say that's quite unlikely. There's laws around kind of financial data and payments data that makes it very tricky to release. The advantage for us here really is with federated learning, we don't have to release or share any data. And a lot of that is to do with compliance, legal compliance, yeah.
One question.
So you mentioned your two clients. Is there a benefit to increasing the clients on the European side, say within countries or the specific banking institutions that you're utilizing? Or is that not necessary in this case?
Sure, it's an interesting question. It might be something that's worth exploring in the future. The way we've split it at the moment is it's around where we hold licenses. So we have a single European license, we will have a US license. But yeah, it could be the case that there's transactions in Germany don't look like transactions in Spain, for example. The other difference there will be there's no issue within Europe sharing the data. But that's not to say there wouldn't be a performance increase depending on what we wanted to do if we really wanted to get more specific with how we train models. Sure.
Great. Well, let's thank Rob again for the great talk.
Thank you.
We're now going to take a break.